Today we're going to look at solving addition and subtraction inequalities. And the good thing about this is you guys already have these skills. You already know how to isolate a variable. You already know how to balance an equation. And you're going to just be applying those same skills to inequalities. So what you've got to keep in mind is we have these two properties, the addition property of inequality and the subtraction property of inequality. The addition property says that you can add the same number to both sides of the inequality and the inequality will remain true. The subtraction property says that you can subtract the same number to both sides of the inequality and the inequality will remain true. So if you add or subtract the same amount on both sides of the inequality, it is still a true statement. Let's look at that as actually solving some inequalities. And as you're solving these, you will also be graphing them. So using that skill that we learned yesterday to graph these inequalities. I'm going to rewrite over to the side here, x plus 3 is greater than or equal to negative 2. And that way I can show all of my work here for you to see. This is the kind of work that I expect to see on your assignment today. You will be working on paper again and turning that in because you will also be graphing. So it's not easy to graph on a Chromebook. At least I haven't found an app yet that I like for it. So we will work on paper for now and it will be just fine. You will turn this in. You should be able to finish during class easily. So here we are adding 3 to x plus 3. Just like when we solve equations, we want the opposite in order to isolate that variable. So the opposite of adding 3 or the opposite of a positive 3 would be a negative 3 or subtracting 3. Whatever we do to the left side of the inequality, we have to do to the right. So I'm going to combine a negative 3 with both sides. So my x is now isolated because when you have a positive 3 and a negative 3, they cancel out. There's 3 zero pairs. It makes 0. My inequality symbol is still there. Be careful. Sometimes we revert to that habit of putting an equal sign. Then I have negative 2 minus 3. If you need to, you can football this to help you remember how to combine those integers. 2 points to the negative team, 3 points to the negative team. Combined together, the negative team has 5 points. Positive team has none. So the negative team wins with 5 points. So that means that x is greater than or equal to negative 5. So on my number line, when I look at my inequality symbol, it's the equal to, so it needs to be a closed point. So I'm going to go to the negative 5 and put my closed point. Then it says that x is greater than or equal to negative 5. So on my number line, to get to the greater than, I need to work to the right of my number line. So I'm going to shade to the right of my number line and put this arrow to show that that shading goes on forever and does not stop. Now, I've graphed on my number line, so I need to check. I need to pick one of the numbers. I'm going to pick right here. I'm going to pick the 2. And I'm going to substitute that into my solution. My x is greater than or equal to negative 5 to see if that is true. So a positive 2 is greater than or equal to negative 5 and ask myself, is this a true statement? Is 2 greater than or equal to negative 5? And yes, it is. So that helps me to know that yes, I should have a correct graphing. Now we're going to do the same thing with this second question. Even though our variable is on the opposite side of the inequality, it doesn't change anything. We've done this with equations where we have worked on both sides of the equal sign. We can do the same thing with an inequality. We can add or subtract anything to either side and it still remains true. But remember, I want you to work with it in this way. Do not try to rewrite an inequality and get that variable on the left side. because you will make mistakes with the symbols. Keep it the way it is. You can work with it this way without any problems. So on the side of the variable, we have where we are subtracting 5, or this is a negative 5. And so what we have to do is we have to get that y by itself. And in order to do that, I have to do the opposite operation. So instead of subtracting 5, I'm going to add 5. Whatever I do to one side of my inequality, I have to do to the other side. So now on the side with my variable, this is going to cancel out. My inequality symbol is the same. And now I've got a negative 6 and a positive 5. Again, if you need to football these, I absolutely want you to. We should not be making integer mistakes. 6 points belongs to the negative team. 5 points belongs to the positive team. So when I look at these two teams, I can see that the negative team won because they have more points. They have 6 points. And then I have to figure out how many more points do they have? They have 1 more point. So then I know that negative 1 is my solution. So negative 1 is less than y. So the first thing I'm going to do when I graph this on my number line is I'm going to go to my negative 1, and I'm going to just put an open point there because I have a less than symbol. I do not have a less than or equal to symbol. Remember, guys, you just have to memorize these symbols. Now then, I know that negative 1 is less than whatever y is. So what would make this statement true? I could put a 4 there. Negative 1 would be less than 4. So if I look on my number line, where the 4 is at is to the right of where I just plotted. So then I know I need to shade to the right because negative 1 has to be less than whatever my y value is. So I'm going to go ahead and I'm going to shade then to the right because negative 1 is less than all of these numbers that I just shaded. And now I can do my little check. Here would be a number 4. So let me substitute that in. Negative 1 less than 4. Is this a true statement to check? Is negative 1 less than 4? Yes, it is. So I know I have at least shaded in the right direction. Okay, guys, today's work. You're solving the inequalities. You are graphing them. And you are doing a check. All 12 problems today need to have the check performed on them.